Hello, welcome to this webcast about DBCSI. This is a tool to help you right-size Oracle databases as you bring them to AWS. My name is David Bayard. I'm a database specialist solutions architect here at AWS. With me today is Arnab.
Thank you, David. Hello, welcome to the session. I am Arnab Saha. I work as a DB Specialist Solutions Architect with the AWS Partner Organization. I work with AWS Partner and help them to migrate to cloud. As a part of this video, we will talk about the database current state investigation tool, which can be used to simplify and demystify the assess and the discovery phase of Oracle database while migrating to RDS. Let's take a look at the agenda for today. We will first start with what is DBCSI and what is the basic intention of this tool. Next, we will talk about how the partner support is done with the DBCSI. We will talk about few of the sizing dimensions that is used to collect the data from the source Oracle database. Now, once we collect the data, we distribute the data in terms of peak and average metrics. And based on the peak and average metrics, we calculate the percentiles. Now, once we collect the percentile, based on that, we generate a few algorithms. Now, depending on the algorithm you choose, you get the target sizing recommendation for your source Oracle database. So we will talk in details about what all the algorithms we have and how you can use them efficiently for the target sizing. Next, we will move on with the batch mode. When I say batch mode, that means you can analyze multiple Oracle databases at one single go. The last, I will talk about the high-level steps followed by a demo of this DBCSI tool. So without further ado, let's get started. Let's first review the tenets of the DBCSI and what it intends to do. So DBCSI is a sizing tool that will help you to size the Oracle database environment on AWS. It wants to make the sizing quick and relatively easy and accurate. We are using simple SQL script so that demystified for you and your customer who understand the reasoning behind the sizing recommendations. DBCSI also give you a way to collect and then display the key performance metrics related to sizing of Oracle database. Then use those key metrics which are collected and help you to define the target values. Now, once we know the target values, it can help you to pick the AWS configuration that can meet those target needs. DBCSI also does a few extra things like suggesting whether this particular database is a great candidate for a standard edition 2 or perhaps converting this particular database to Postgres. DBCSI will mine the historical performance metric that is going to be resident in the Oracle database. And we do that either by Oracle AWR or Oracle StatsPack. The data is collected via SQL Plus script that can be downloaded from the DBCSI web app. Just make sure the DBCSI tool works with SQL Plus command line utility. Do not use any other SQL interface like Toad or SQL Developer to generate the output file. Let us talk about the key support parameter for this tool. So this is not an official AWS tool. This tool is built by David and it is supported through the AWS SA community. We know we strive to make it helpful and useful, and that's the reason it is publicly accessible but not publicly advertised. Now, Oracle is very strict on licensing and makes it easy for the customer to accidentally use the unlicensed feature, such as Oracle Diagnostic Pack. So be very careful in protecting your customer from accidentally using Oracle Diagnostic Pack feature that they may not have licensed. If the customer did not license Oracle Diagnostic Pack, they should not run the AWS AWR miner.sql. We provide a choice of script, and customer should always be advised to use the AWS StatPack miner SQL file when they do not have the Oracle Diagnostic Pack licenses. Now, this tool has been created on the best effort basis and it is always built to be secure. Now, we make best effort to make this tool accurate and useful. It makes some good recommendation on the target sizing depending on the 5 key sizing parameters. But at the same time, the customer should also perform some performance testing on the target environment, and depending on the performance testing result, they can size up or size down on the target instances. This tool has been built to be secured, so there is a lot of focus on keeping the data isolated from one user to another. We are not collecting any PII data as a part of this tool, and we are not collecting any schema name, table name, text or SQL statement as a part of this data collection. With that, I will hand it over to David, who will walk us through the key sizing dimensions and talks about the peaks and the average and how we calculate the algorithms for the better target recommendations.
Thank you. Let's now talk a little bit more about how DBCSI works. One of the key features of DBCSI is what we call the auto right sizer. The auto right sizer's objective is to look at the raw performance data that we collect, convert that into minimum target values for some key sizing dimensions, and then ultimately map those minimum target values to various types of AWS configurations. So what are these sizing dimensions? There are 5 primary sizing dimensions used by DBCSI. They are memory, vCPU, I/O throughput, IOPS, and disk space. On the screen, you can sort of see a snippet of the screen of the auto right sizer showing how those calculated minimum target values are presented. Let's look a little bit deeper at how DBCSI calculates these minimum target values for the different sizing dimensions. Under the covers, the data that DBCSI collects are essentially time series of different metrics. You can see 2 different time series on the chart on this slide. The time series is a series of data points represented by these tiny little dots, for example, on the red line. Both of these time series correspond to I/O throughput, but you'll notice there's 2 different flavors. One is what we call the averages, and one is what we call the peaks. To understand that a little bit better, you need to understand how AWR or StatsPack work. AWR or StatsPack collect data points for different what they call snapshots. And typically, customers will collect these snapshots on a recurring interval, by default 60 minutes, but customers often change that interval to be 30 minutes or 15 minutes or something like that. So each of these intervals, say they're 30 minutes, would be represented by a different dot in the time series. For the averages, that dot represents the average value of that metric across the entire snapshot interval. So if it was a 30-minute interval, this might be the average value of that metric from, say, 11 a.m. to 11:30 a.m., if that was the particular start and end time of that interval. The peak throughput, or the peak metric, represents the single highest value seen by Oracle during that interval. So a peak will be higher than the averages, but the peak value might only have existed for, say, 5 or 10 seconds of the interval. Next, DBCSI takes those time series and calculates what we call percentile values. You'll see these referred to by nomenclature like P99 or P90. So what's a P99? P99 represents a 99th percentile value. In other words, 99% of the data points for that time series fall within that value. So in this example, we're looking at averages of the throughput, and we can see that 99% of the data points collected fall within 850 megabytes per second or less. The P90 in this example is 530 megabytes per second. We use the percentiles as part of the different choices of algorithms that we give you. So we give you the choice of algorithms for each of the 5 key sizing dimensions. And you can change the algorithm to better suit your or your customer's preferences, or to run different scenarios. Let's look at some of the algorithms available, say, for the vCPU calculation. Let's look at 2 examples. This is the same data in both the left and the right-hand side of the screen. On the left-hand side of the screen, the algorithm was specified as the larger of the P99 of the averages or the P90 of the peaks. And in this case, using that algorithm for this data, the target value for vCPU is calculated as 1.8 6 approximately vCPU. On the right, the algorithm is switched to the larger the P99 of the averages or the P97 of the peaks. And with this tweak to the algorithm, the target value actually became different. In this case, it worked out to 2.4 vCPUs. Again, you have the flexibility of DBCSI to choose the algorithms that make sense for your particular customer and situation. And by the way, you can manually override any of these algorithms and enter your own target values for these 5 key sizing dimensions. One more thing to mention before we move on to a demo is what we call the batch mode. So as you start to use DBCSI, I want you to be aware that there's also a batch mode, and this can make it easier for you to work with environments that have multiple Oracle databases. You can upload a batch of databases in one single action in the web interface, or you can group databases that have already been uploaded together into a new batch. Once you have a batch either uploaded or defined, you can then auto right-size the entire batch of databases all at once, which is quite a time saver. To use the batch functionality, you can just navigate to the add page of DBCSI and tell us you want to add multiple databases. From that page, you'll then have the ability to download a zip file. And within that zip file is a shell script and a properties file. You can populate the properties file with your list of databases, essentially providing connect string type information. And then the shell script will simply loop through each database in the properties file, connect to it, run the data collection script, and then ultimately take all the different databases output files and zip them together. At this point, I'm going to turn it back to Arnab, and he can walk you through a quick demonstration.
Thank you, David. Now let me walk you through the basic usage flow while using this DBCSI tool. It's a simple 3-step process. The first, you need to create the account. Next, you need to generate the data from the source. And the third, generate the configuration. In the create account phase, you will use the DBCSI URL and your corporate email address to create an account. Once the account is created, you log into the DBCSI tool to download the miner script. It could be the AWR miner or the StatsPack miner from that section. Next, you run the script on the databases using SQL plus CLI. Usually it takes few seconds to a few minutes for the script execution to be completed. Next, on the generate configuration phase, you need to upload the .out file, the output file that is generated from the script. Multiple databases can be uploaded at once using the batch mode. Once the database upload is completed, you can use the auto right size by selecting the assumption and the various algorithms. Next, I will show you a quick demo on how to use the DBCSI tool and how you can analyze the single databases and multiple databases at one go. Now this is the homepage of the database current state investigation tool, and once you come first time on this tool, you need to create an account. The first step, you click on create account, you provide the username, password and your corporate email address along with your phone number. Now once the create account is completed, you can click on sign in, and here you can provide your account ID and your password to log in into DBCSI. Once you provide the username and password, you click on sign in. Once the sign in is completed, it will take you to the first page of the DBCSI. It will also give you 3 sample datasets, which you can see how the other datasets or how the other samples look like. The first step is to go on add. Once you click on add, it will give you the following options. You first need to select the database you are investigating, whether it's an enterprise edition with diagnostic pack or whether it's a standard or enterprise edition with StatsPack. Now, depending on the source database you want to analyze, you can select the script that you want to work with. Next, you download the data collection script from your database over here. When you click on here, it will download the data collection script on your local desktop. Now keep in mind, we keep on updating the data collector script, so it is always advisable to download the latest version from the DBCSI website. The third step is to run the script against your database, and this script will generate an output file. And the fourth step is to upload the output file over here along with the details of the database. So let me go over and run the script against my database. The first step, you need to log into the Oracle database. Once you log in, you can run the script, which is aws awrminer.sql. Now this particular database have diagnostic pack enabled, and that's why I'm using the AWR miner. If I do not have the diagnostic pack licensed, I could have used the statspack miner SQL file. It will ask you for the authorization. Once you provide that, the script will run against the database and it will generate an output file. So as you can see, it is generating the output file pretty fast. It takes a few seconds to generate this particular output file. And at the same time, the script will also confirm if you have the diagnostic pack licensed for your database or not. Next, I will transfer the output file and upload this into the DBCSI tool. Now once you populate the output file, you can upload the output file directly over here. You click on browse, and once you upload the output file, you can give the name of the database. You can give a little bit of a description what the database is doing, and also the customer name. Let's say I'm using it as self demo. Next, you click on submit. Now once you click on submit, the DBCSI tool will upload the output file, and you click here on continue, and it will get the data. It will try to analyze the data. Now while it is analyzing the data, let me show you how you can read the data. I have already uploaded an output file before, and the data uploading is completed. So I will continue the demo with this particular database. Now as you can see, there are two options. One is view metric and one is auto right size. Now when you click on view metric, it will take you a page where you will be able to see all the information related to that particular database. On this page, you will be able to see the basic information of the database, the number of storage object and the code object, and the features being used in this particular database. For example, you can see it's an Oracle database with 19c as a version. It talks about the DB ID, the version of the AWR miner script we are using for this DB analysis. It talks about the code objects as well. Moving on, it will also talk about the feature. Let's say we have find when audit, parallel SQL query execution, transparent data encryption, and partitioning. Moving on, it will talk about the CPU and the number of cores in this DB. Next, you can click on the CPU metrics to look at the average database CPU and the average peak CPU. Now, depending on the workload, depending on the resource usage, the DBCSI will be able to tell you what are the average CPU over a certain period of time. Next, it will also talk about the peak, which is the non-sustained database CPU usage. Depending on the analysis or depending on the algorithm that is being used, it will auto-suggest the number of vCPUs for the target database. Similarly, if you move on to the memory metric, you will be able to see the amount of SGA and the PGA allocated for that particular DB. And depending on the auto-suggest algorithm, it will also suggest you the amount of memory suggested for this database. Looking at the workload metric, the IOPS and the throughput. This is the average IO request per second, and we are segregating the IO in terms of the reads and the writes. On the graph, you will be able to see what are the spikes we see in terms of the read IOPS and also the write IOPS. And depending on the algorithm, it will suggest what is the suggested IOP for the target database instance. And this is the analysis for the average IOPS, and depending on the peak IOP, it will also give you suggestions. Moving on with the IO throughput, similarly, you will be able to see the graph for the reads and the write throughput based on the average data collected and as well as the peak non-sustained throughput as well. This particular tool will be able to tell the disk space metrics, and depending on the space collected and depending on the disk utilization, this is the total disk space collected of the data collection script. And there are a couple of other metrics as well. Let's say the backup metrics, where it talks about the redo generation rate. It will talk about the physical write over the time, and also the wait metrics as well, where you will be able to see all the wait events which is associated for this database. In the end, you will be able to see this button where it says mapping to AWS. Now this is the auto right sizer, which is the target recommendation engine for this DBCSI tool. Now you can click over here to get to the auto right sizer page for this database. This page talks about the auto right sizer functionality. Auto right sizer is where the mapping of the AWS is performed. Now this area has several sections. The first one is the overview of the database. Now this is very similar to the information provided in the view metrics section. You can scroll down and you can check all the metrics that has been collected as a part of the data collection process. And at the same time, if you click on hovering on any of the attributes here, the display will pop up with further information. Next, we will move on to the algorithm choices. Now this section allows the changes to the default algorithm used to generate the configuration. It is very important to adjust this algorithm for certain scenarios where the default option might not be suitable. The algorithm allows adjustment to all the sizing dimension and further tweaking. We do have some additional preferences and control. If you want to use the CPU optimized instance classes, you get the choice to highlight it over here. You also get the choice for the AWS pricing preferences, the EBS volume, whether you want GP2, GP3 or IO1. At the same time, if you want any local storage preferences. In the end, you do get a choice if you want to estimate Aurora as a part of this evaluation. In this section, you can tweak the algorithm choice to generate different name scenarios and use them to compare the pricing and capabilities for your migration scenarios. Now let's change few of the algorithms on the top. Let's say for the CPU, I want to take the 99th percentile of all the averages. For the memory, let me select the sum of the SGA and PGA plus a greater of 2 GB or 20% over it. For the IO throughput and algorithm, let me select the 99th percentile of all the averages. Same for the IOPS. For the disk space, I will be using total DB size with a 15% expansion room. For the RDS Oracle preference, I will still use the Enterprise Edition, bring your own licensing. Next, for the optimization and the goal preference, I want to use optimized CPU. Next, for the pricing preference, I will go with 1 year reserve instances. For the volumes, if it's a production workload, it's always recommended to use the IO1, so I will select that. And with this particular selection, I will create a new scenario. Let's say I call it Demo 1. When you click on Create Scenario next. So with the choices of algorithms provided, the DBCSI Auto Right Sizer tool is going to create the scenario for you. Once you scroll down on this page, you will be able to see the target output for the scenario listed. Now you can use the Show Config button to produce a report with details about the estimated configuration. The sizing information is provided for the budget estimate and there are no warranties or guarantees. So you should plan on refining a proper sizing during the performance testing phase of your migration. Now there are several sections on the Show Metric report. You can output this report in PDF format by using the print option. As you can see over here, it talks about the current state of the database and it gives us a detail of the target vCPU, the target memory, the IOPS and the throughput and the disk space depending on the algorithm that I am using. Next, it will talk about the RDS Oracle summary, the licenses that is required as a part of this target configuration along with the monthly cost. Now let's go ahead and create a different scenario. On the previous scenario, we did not use anything with the Aurora estimate. For this one, let's create an estimate with Aurora as well. And I will keep rest of the algorithms as same. I will give the scenario a new name and I will click on Create New Scenario. Once the new scenario creation is finished, we will be able to see this particular demo Aurora scenario over here. And when I click on the Show Config, it will give us the details of what are the particular cost or what is the Aurora target instance size that is required. You click on Show Config. The configuration detail will show you the target vCPU, the memory and the algorithms that has been used. It will talk about the Oracle summaries as well and the estimated monthly cost. And moving on the bottom of this report, it will also talk about the Aurora consideration. So this report will tell you the Aurora PostgreSQL alternative configuration and it will tell you how much monthly cost will that be if you use Aurora Postgres for this particular database. Now you can keep on creating more scenarios depending on the algorithms that you choose or the preferences you have, and that will be coming over in this algorithm target matching section. In the end, you have the ability to download all this comparison in a CSV file. Next, we are going to talk about some of the batch functionality. The batch functionality will help you to work with multiple databases as a single unit. Now there are several batch features that has been built into the DBCSI tool. We try to make it easier and more efficient to run the data collection script against multiple databases and at the same time upload the multiple output files into the web application as a single action. Let's go back to the main page. Now this is the main page of the DBCSI where you are gonna see looking at the individual databases. This is what we call the single database view page. On the same page, if you click on batch list view, it will take you to the page where you can see all the batches. At this time, there are no batches created for this demo. If you want to create batch, you need to click on add. Now, if you want to really go back to the single database addition, you can click over here and that will take you to the single database addition page. Now over here on the batch mode, if you look at, there is the option of downloading this particular script. Once you click on the section, the second point, it will download the zip file for this batch mode. Now this particular zip file contains few of the files. So it is a zip file, it has a shell script, a property file and the readme. So the readme will tell you what to do after you download the shell script. So you need to populate the property file based on the sort of template example that we have, and they will add to the list of the single database. Now each of the database that you want DBCSI tool to collect the data, then they will execute the shell script. The shell script will loop through the individual databases while collecting the data. And at the end, it will bundle all of the individual database output file into one single zip file. This is the same zip file that you need to upload directly into the DBCSI tool. Now, at this point, you can see there are two versions of the shell script and the properties file. The first version uses the simple property, which is a comma separated value. The second version uses the exact same format of the property file that we used in the schema conversion tool multi-assessor feature. If you are already going to be using the schema conversion tool multi-assessor assessment across multiple database and schema, you can just reuse the same property file for the SCD exercise. Now once you run the script across multiple database and you have your zip file generated, you can come back to this particular DBCSI page. You can provide a customer name, the batch name and the description. And you can select the output file to be uploaded. So once you upload the zip file for this particular evaluation, you click on submit. Now one thing to note that if you did not use the shell script to create the output, let's say the customer used the SQL plus script and ran it 5 times manually for 5 different databases, you can still use the interface to upload all of the 5 files at once. The trick is just simply put all the 5 files, 10 files or like the multiple files in one single directory, and you can zip up all those files and create your own zip file. And then on the previous page, you can specify the same zip file here. So it's a handy feature, especially if the customer is singularly working with multiple databases and emailed you 10 output files. You can simply put them into one file, zip it and upload them all at once. Now once the batch upload is completed, you can see the status is ready and it will talk about the number of databases included as a part of the batch. One another reason we create the batches of databases that we can use the auto right sizer functionality for the entire batch at once. Now let's see how it looks. And because I am using the batch mode, I can select all of the algorithms all at once. Now depending on the auto right sizer, I can select the algorithm, and depending on the algorithm I select, the DBCSI right sizer tool will be able to create the target databases. Now since I have clicked on batch, I can see multiple databases listed here. And once I come to the auto right sizer, I can select the algorithm choice, and depending on the algorithm choice, I can create a scenario. Now when I click on the target value, the auto right sizer will loop through all of these databases and it will prepare a suggested configuration. Now you can see this will save a lot of time from having to do this manually for the individual databases. Let me select few of the algorithms and select a few of the additional preferences as well. Let me click on create scenario. Now this can take a few seconds to a few minutes depending on the number of databases we actually need to create as a part of this auto right sizer process. Now once the scenario creation is finished, you can see all the target values and the matching configurations based on the above algorithm that you selected. You can see all of the database analysis all at one go. You can look at the vCPU, the memory, and the target IO throughput and the IOPS. For a detailed overview, similar to as we discussed earlier, you can click on Show Config and you can see the configuration of the source database, the target database, and as well as the monthly cost of running the same Oracle database on RDS. In the end, if you want, you can click on the print button to get the PDF output of this recommendation. You also have the option of exporting or rather downloading the entire dataset into a CSV file so that you can share it with your respective stakeholders. Thanks again for joining us today. If you like today's session or have any comment, please feel free to email us. AWS is big on feedback, and I wanted to remind you that your feedback will help us drive continuous improvement or address any gaps or concerns. I hope to see you in our future sessions. As always, happy cloud computing.